Hey there, welcome to class, and we continue with chapter 3, coordinate geometry, circles. This is where we were yesterday as we continue discussing the importance of coordinate geometry. Now we are in circle equations, and that takes you back to what you did in year 11 and year 10, IGCSE concept. So basically, in Cambridge International Mathematics, be it IGCSE or A-level, the equation of a circle in coordinate geometry is an important topic. And we are going to be giving some comprehensive explanation and clear definition and interpretation on what is required in terms of circle equations. First of all, we are going to consider the standard equation. So if we consider standard equation of a circle with center at AB, so if we take a center of the circle, to be at A, B as the coordinate. In terms of this, the equation of a circle with radius, let's say that you have the radius r, then it means that we are going to have x minus a, so it is x minus a squared plus y minus b squared. And this is equal to r squared. So this is the standard equation of a circle. Now, when we look at this equation, the distance formula is used to define a circle. The distance formula is used to define a circle, right? So a circle is a locus. And what do we mean by a locus? It is set of all points. A circle is a locus because it is a set of all points, right, that are fixed distance, and that distance is what we call distance r from a point AB, right, from a point AB. So we can, if we have x and y, if we have x and y, and this xy lies on the circle, and we look at the distance from x and y to AB, right, this must be equal to r, such that we can put them under the square root. We simply have x minus a, so x minus a squared plus y minus b squared, y minus b squared. So these must be equal to 2, or we can say in this case, this is equal to r. We come back there. So that is equal to r, right? So a squared, if we remove the square root, this is supposed to be under the square root, such that if we remove the square root to get r, we will simply have x minus a squared plus y minus b squared. So this is equal to r. So we have some special cases in which the center is at the origin. So if the center is at the origin, you have 0, 0. This is origin. So the equation becomes x squared plus y squared equal to r squared. So these are special cases. So if you are asked to find the equation of a circle, let's take a point. Let's say I take a point 3, negative 2, for instance. And maybe the radius is equal to 5. the equation of the circle becomes, we have 3 negative 2, right? So the equation of the circle becomes x minus 3 squared, then plus y. Here y minus b becomes y, minus minus becomes plus 2 squared. So this must be equal to r, which is 5 squared, 25. So this is one of the ways we can easily replace this in terms of finding the equation of a circle with the center. So how is it used in coordinate geometry? We use the equation of the circle to check if a point lies on a circle. So if a point lies on a circle, as you can see in this circle, we can use the equation of a circle to check if a point lies in there. And we are going to see that in examples. We also use this to find intersection. So intersection of a circle with a line. So in this case, we can look at solving the system. So it is also using transformations. Translation affects the center. When you translate a shape or an object, we will look at that. Later on, we discussed earlier on about, in IGCSE, we talked about lines of symmetry. We talked about reflections. We look at the flipping of an object. So all these translations can be explained using a simple equation of a circle. So let's now take some examples and see how we can solve some practical example or practical problems that involve equation of a circle. And even here, just to note, this is also r squared, because the square root only affected the left-hand side. So this is r squared, right? So let's look at now some examples. Find the center and radius of the circle. You are to find the center and radius of the circle with the equation. So the equation is given as x squared. So this is x squared plus y squared, right? X squared plus y squared minus 10x plus 12y plus 12 is equal to 0. So we are supposed to find the center and the radius. First, we need to rearrange the equation to the form that is required. So we already have x squared, y squared. So we can have x squared minus 10x, right, plus y squared plus 12y, right, making sure that they are together, plus 12. So this is equal to 0. Now we can complete the square. Quadratics, one of the methods we use in solving quadratic equations. So here, let's complete the square. If we want to complete the square for x and y, because we have x squared and y squared, so we need to complete the square for x and y. For x, we have x squared minus 10x. So we can have x minus 5 by factorization squared, right? This will give us x squared and minus 10x. And then this will be minus the square root of 5 is going to be 25, right? So we have minus 25 as the part of x in terms of completing the square for x. So we can complete the square for y. This becomes y minus, this is 12, so it is minus 6. Right, you simply divide this 12 by 2 and square it. So minus 6 squared, and what is the square root of 6? 36. Then plus 12 equals 0. Plus 12 equals 0. So this is the first step that we need to do. So from here, we can try to rearrange this form. So we have x minus 5 squared. We have x minus 5 squared. And then we have y minus 6 squared. So we can add that up. Y minus 6 squared. So this must be equal to, we are going to have 49, right? Yes, because here you have 25. We have 25, 36, and we have 12. When we take them to the other side, if we take 12 to this side, it becomes negative 12, right? And we have negative 36 as well, becomes positive 36 minus 12, and then negative 25, positive 25. So this becomes 49. Correct. So this is the next step, trying to arrange into the correct form. Now, looking at this arrangement, our A value, if you look at the center becomes 5 because we have 5, negative 5, and negative 6, right? Negative 5, negative 6. So this is positive 6. Sorry about that. So this becomes 5 and negative 6 as our center. And the radius is simply 7 because we know the square root of 7 is 49. So r is equal to 7. Right. And you can solve these two equations in order to get this value because you have x minus 5 equals 0. X is simply going to be positive 5. Right. So that's how you get 5. And if you solve y plus 6 equals 0, you simply have y equal negative 6, right? So this is the center with radius 7. Since we know that r is nothing but the square root of 49, which is equal to 7. So this is how you are able to find the center and radius of a circle with that equation, x squared plus y squared minus 10x plus 12y plus 12 equals 0. Let's look at the next problem. Here you have exercises. I've included the solutions, more clear sample of the question number 12 that we just solved. You can look at it and you see that the value for A is 5, value for B negative 6, R is simply root 49, which gives you 7. So try to attempt these exercises as we proceed to the next subtopic. So now we are in 3.5, point of intersection and circle properties. Point of intersections and circle properties. Conceptual understanding. What did you know from year 11 IGCSE? You know that the equation of a straight line is given by y equal mx plus c. You know, is given by y equal mx plus c, right? This is what you know, basic knowledge, right? So when m, we know what m is. M is a gradient, right? M is a gradient of the line. And we know that C is nothing but y-intercept, right? So if M and Y and C are y-intercept, from chapter 1, you learned that you can find the point of intersections of a line and a curve by solving their equations simultaneously. That means that when a line touches a curve in exactly one place, we call that line a tangent. You can see this line, it touches the curve in exactly one place. So you call that line tangent. It also means that there will only be one solution when solving the equation simultaneously. There will only be one solution because the line touches the curve in one point. So it is a tangent. So when solved simultaneously, there will only be one accepted solution. If you form a quadratic equation, there will be one repeated root. And we talked about the discriminant. So b squared minus 4ac must be equal to 0 because you are going to get only one repeated root. And we are going to see this now in the exercises below. Look at this question, number 14. Find the set of values of k. Find the set of values of k, right, for which the line acts the curve. So we have a curve equation and we have a line equation. A curve equation is given as y equal x squared plus 3x plus k. So let's look at this. Both equal to y. If both of these equations are equal, in this case we have they met when x squared plus 3x plus k, right, is equal to x minus 2. X minus 2. Even though here you have x equal to y plus 2. You need to represent all the equation in terms of x. So our y, therefore, in this case, is going to be what? X minus 2. Taking this 2 to the other side becomes negative. So x squared plus 3x plus k is equals to x minus 2. Right. If we rearrange this as a quadratic equation, we are going to have x squared plus 2x because we are going to take x. 3x minus x gives us 2x. Then we are going to have plus, we have k and we have 2. So this becomes k plus 2. This 2 becomes plus when we bring it to the left hand side. And this must be equal to 0. Right. Now, there are two distinct roots when b squared, the discriminant, minus 4ac is greater than 0, right? So if there are two distinct solutions, we are going to substitute this in this formula of discriminant. Our b becomes 2 squared. So this is 2 squared minus 4ac. It is 4 times 1, right? Multiply this by c, k plus 2. So this must be greater than 0. this becomes negative 4k minus 4. 2 squared is 4. And this is greater than 0. So minus 4k is simply greater than 4. So k, if we divide both sides by negative 4, k become less, because when you divide by negative sign, the sign of inequality changes. So it is less than negative 1. So we use these inequality signs throughout as we solve. Remember, by solving the discriminant here, our value for A is 1, our value for B is 2, and our value for C is K plus 2. So this is what is required in this question. Look at number 15. A line has equation y equal 4k minus x, and the curve has equation y equal 3x minus kx squared, where k is a constant. Find the true values of k for which the line is a tangent to the curve. So let's start with the first one. If we look for the line and the curve, they will meet when 4k minus x, 4k minus x is equal to what? 3x minus kx squared. Right. So if we try to rearrange this in the form ax squared plus bx plus c equals 0, this becomes kx squared. It becomes positive, right? It becomes positive. Kx squared, then minus 4x minus 4x, right? Minus 4x plus 4k, because you have negative. If we take x, we have 3x and we have negative 1x. So that becomes negative 1 plus 3, or 3 plus negative 1, in which case. So when you take the negative this side, it becomes positive. So 3 plus 1 gives us 4. So we have negative 4x plus 4. And this is 4k. So this is equal to 0. Right. So we can rearrange this to be equal to 0 as we have done. So the line is a tangent. So there is one repeated root, because we know if a line is tangent, then b squared minus 4ac must be equal to 0. Therefore, our a in this case is going to be, what is our a in that equation? We have b squared, so our b here is negative 4, right? Negative 4 in this equation. So if we substitute, it becomes negative 4 squared, negative 4 squared minus 4ac. Our a is k. We have k. So multiply that by k, and multiply by c, which is 4k. So this is equal to 0. Right. 4 squared is 16. So we have 16 is equal to, when we take 4k and negative 4k to the other side, we will have positive 16k, positive 16k squared. Alright. So k squared is simply 1, where k is going to be 1 or k is going to be negative 1. Right. B, we can now substitute, because hence find the coordinate of the point where the line touches the curve. So let's take a different color. This implies that when k is equal to 1, x squared minus 4x plus 4 is equal to 0. Is that correct? Solved by factorization, we can have x minus 2, that is the divide 4 by 2, and then we can have x minus 2, x minus 2, x minus 2, right? So this is equal to 0. So x will be equal to 2 when you solve, or y equal to what? 4k minus x. So this becomes 4 minus 2, which is equal to 2. When k is equal to negative 1, we are going to have negative x squared minus 4x plus 4 equals 0, such that we can have x plus 2 and then x plus 2. By solving, x is equal to negative 2, or x is also negative 2. So if x is equal to negative 2, y minus 4k, y minus 4k minus x is what? It becomes x, that becomes negative 4 plus 2. So we have sorry for that error. Y supposed to give us supposed to get the final answer y. Let's take a different color. So y equal to, first we have y equal 4x minus, it is 4k minus x. So if we have 4k minus x, y will simply be equal to negative 4 plus 2. Plus 2, such that we are going to have this as negative 2. Sorry for that error that happens in times of recording and all that. So let's look at, you can also check here and try to get and follow through. So we have -2 as the value for y, line meet at curve 2, 2 and -2, 2. So the equation asks for the coordinates. So this is the required solution for this. Let's look at the next question. Question 16. So you are supposed to determine the equation of the tangent to the circle. Determine the equation of the tangent to the circle centered as C with equation x squared plus y squared minus 2x minus 4x plus 5 equals 0 at the point 8, which is given. So here in this equation 16, we complete the square of this particular equation. So we have x minus 1 squared minus 1 plus y minus 2 squared. -4 will be the square root of 4, then minus 5 equals 0. Solving, you get c to be 1 and 2, the coordinates. And when we find the gradient of AC, the change in y by changing x, we simply get 3. So the equation of the tangent becomes x plus 3y minus 17 equal to 0 in a simplified form. Look at question number 18. The diagram shows a circle centered C with equation x minus 7 squared plus y minus 6 squared equal 25. PQ is a diameter where P is given at the point 39 and Q is 11,3. R is 12 and 6. It lies on the circle. Show that the line perpendicular to QR, the line perpendicular to QR, this line here, QR, and passing through R goes through P. So let's look at QR. QR has which gradient? We can check the change in y over change in x. The change in y, QR, is at this point 6.6. So we can take 6 minus 3. So it is 6 minus 3. Divide that by change in x. 12 minus 11. So this becomes 3. Right. So the gradient is 3. Gradient of perpendicular line multiplied by -1. So we are going to have perpendicular line. It becomes -1/3. The equation of the perpendicular line through the point we are given, the point is 12,6 QR. 12,6. We can solve using the formula y minus 6. This will be equals to our gradient -1/3 into x minus 12. So this becomes y is equal to -1/3x plus 10. So when x is equal to 3, y is equal to negative 1 over negative 1 over 3, then multiply by 3. This will give us, if we add to the equation, plus 10. This is going to be 9. So the point that we are looking for is simply 3 and 9. It lies on the line. Point 3, 9. This point lies on the line. Check question 19 and confirm the answers below, and look at the exercise 3.5 as it is indicated. Try to follow through the exercise, and that would be the end of coordinate geometry. I've included summary exercise question, that is exam style question for Cambridge edition. Try them. I'll be leaving the link below the video so that you check the answers. So generally, what we have done in this topic, we have looked at the midpoint of a line segment in the form x1 plus x2 divided by 2, y1 plus y2 divided by 2. So you use the formula in order for you to find the midpoint. We have also looked at the gradient of the line. We have looked at the length of a line segment, taking the square root of these x and y values. We look at the parallel and perpendicular lines, and we know that when two gradients are equal, they are parallel. And when we multiply the two gradients and we get negative 1, it shows that it is a perpendicular line. We've also looked at the equation of a circle in the form x minus a squared plus y minus b squared equal r squared. And that shows us a standard equation of a circle. And then we look at the tangent to a curve when the line touches the curve at one point. It means you are simply going to get one solution. So the discriminant must be equal to 0, and we have seen this in computations. So try and finish up with the homework given, and check your questions. Check the answers in the link below the video. See you in the next video.